4. So the total number selected can be 1, 2 ball, you select 2, you select 3, and the maximum is what?
4.
X denote the total number of balls selected, 4. Okay, so now let's have a look. So now what are the possible outcomes? Because it's without replacement. So we are going to use 3 diagrams. I'm going to use 3 diagrams to show it to you. How is the situation like? Okay, first ball. First ball, there are how many outcomes? 2 outcomes, either red or green. Am I right? No. They say ball are randomly selected without replacement until a green ball is selected. Listen, until a green ball is selected. And X denote the total number of balls selected. So we are talking about green ball until a green ball is selected. So anyone, can you please tell me the possible value of X that I have here is right or wrong? Okay, never mind. Let's have a look at it. Let's have a look at it now without replacement. That means if the first one I select is the red, then I will left with 1 red and 2 green. Am I right? So I will have 3 balls here. All right? So that means they say ball are randomly selected without replacement until a green ball is selected. So if the first one I select is green, is red, so I have to continue to select the second one. Am I right? I can get red or green. So here I stop because I got green ball already. Here I also stop selecting. Am I right? So this is select 1 ball. This situation is select 2 ball. But if I get red, then after that, I take out. If the next one is red, so do I have any red inside here? I only left with 2 green, correct? So this is the first time you select. This is the second time you select. So the third time you select, definitely is a green. Am I right?
Yeah.
So yeah, so definitely is a green. So third. So you have to be very careful. So can this be here? So when we read the question, we cannot just let X denote the total number of balls selected. I have to read the sentence before that. Ball are, you see, Mr. also can make that mistake. So when you read statistic question, correct, you have to be extremely careful. Every sentence is important. If not, you misinterpret the whole question, just gone. Okay, so now, how are we going to count the probability? So the first one, to get the rate, the probability we always put at the branches here. Why is it half? Can you tell me? Can someone tell me why is it half?
Because 2 red and 2 green.
Yeah, because half of it is red, half of it is green. So same thing. So now, what is the probability of getting a green by selecting only 1 ball? The chances is half. Correct? Okay. So this one become, if the first one I get is red, so how many red left behind? Only one out of 3. Right? So there are still 2 green. So select 2 balls. The probability will be half times 2/3. That is 1/3. Are you okay? Are you okay? How to get the probability for each branch of each outcome for the tree from the tree diagram? So the answer is 1/3 here. Okay, now to get the third ball, this is a situation. You get red, red, and green. So I told you is the n, correct? So probability of getting a red, and the next one is the red, and the next one is the green. So I'm teaching you different way of writing it. So is the probability for the first one is the red, times by the probability, the second one is the red, and times by the probability, the third one is the green. I have only one outcome. Okay, so this is half. The second one is 1/3. And now, what is the probability of get the green in the third one? There are 2 green, there are 2 balls in the bag, and there are 2 green. So it's 2/2, which is 1. Okay, so I get 1 out of 6. Does this total up equal to 1? Let's see. Half plus 1/3 plus 1/6. Do we get 1? Right? So this is the probability distribution table. Are you okay?
Yeah.
Any question? So if this type of question I can ask. I can transfer this question to become exam question. I can ask you further. Okay. Instead of asking you to find the mean, I can ask the question. What question can I ask further? What question can I ask further? Can someone give me? What is the further question that I can ask? Hello? Student? Try.
Maybe you can ask maybe find the mean something.
No, I will not ask you to find the mean. I will ask question like,
what are the odds that you only get green
what
neutron
is
scraps?
the expected total number of ball selected until a green ball is selected. Can I ask like that? So if I ask the expected total number, so what does that mean? I will not ask you to find the mean. I will ask like that. Or I can say in the long run, how many, what is the total number of ball selected until a green ball is selected? I can also ask like that. So this one means you have to find the mean. Okay, so can you find the mean? Can you use your calculator and find the mean?
Hold on.
Please, everyone start to work with your calculator.
Got 1.666667.
Okay, sure. Is it 1.6667?
Yes.
Okay. So if I ask, if I ask you, right? So this got the expected number, but for this case, it's not suitable lah. Okay. I can say if I repeated this experiment, so listen, expected number, even is a discrete, you don't have to round it off to, you don't have to round it off. It can be a decimal. Are you clear? It can be a decimal, so you don't have to round it off. You round it off to 3 significant figures. So it's nothing wrong to state like that, especially is for expected number or mean. Okay, so you expect to draw 1.667 number. So if I repeated this experiment, okay, 10 times, that means I have to draw 16 balls before, okay, I can get a green ball, right? Minimum 16 balls. Okay, do you get me? Can or not? So build probability density, build probability distribution function. So depend on the situation. I can use tree diagram. I can use the chart, depend on the situation. Like 14, you have to use the chart. Okay, can I move on?
Yes.
Yeah. Let's move on with, okay, yesterday we have done page 157, 195. We have done question 11, correct? I told you. Okay, now let's try. That's how I got. Okay, let's try question 9. Question 9. Page 195. Okay, question 9. Okay, everyone, you have to read the question by yourself. I'm reading also. Even I've done this a few times. Okay. Can you tell me what is the answer for A? Offensive?
15%.
Huh?
0.15.
1.5. Yeah. So you know, so everyone know. Very good. Okay, and this one is 0.5, right?
Yes.
Offensive is 0.5. Good. So you see, you list down properly. Then calculate the expected number of points per game under each strategy. So look, so the probability, expected number of points per game under each strategy. Okay, now let us denote our variable x. So how should I denote? X is the point gain, all right? Or point awarded. If you want to, according to the question, point awarded. Okay, so for offensive, so you build the table, you don't rush, you build the table. Okay, so the X, win, 1 point, win is 3 points, lose is no point, draw is 1 point. So how you do it? This is a probability. We start with the smaller one, then we write down the probability. Then you key into the calculator. Then you get the expected number of points per game. You find the mean. See or not? Can you please? So this is for the offensive. So for the defensive, you also write down the table. You build the probability distribution table. When you do statistic, correct? Don't rush. 0, that is for lose, 1 point for draw, 3 points for that one. So I write down properly, so I have some visual so that I fill in the correct number. Everyone, are you with me?
Yes.
Good. Okay, so can you tell me the expected point?
For offensive is 1.05.
1.05.
Yes.
And then for defensive is 1.1.
For defensive, the expected point?
1.1.
Yeah. So for defensive is higher. Yeah. So do you know in your book how they write the expected value for the variable? Do you know they use this E, then the X? So E represent the word expected. Are you okay? So I prefer to write as expected so that I know. So, but you have to know, when people ask you for EX, you know it's expected. Hello? Are you okay?
Your distribution, probability distribution for defensive doesn't add up to 1.
So I'm wrong. So where did I go wrong? You see?
0.243.
Yeah, this is 0.2 for win. Thank you. You see? I can transfer. That's why when we talk about statistics, if you transfer, correct, you have to be very, very careful. Here is for 3 point is 0.2. Thank you. Okay, so we're done with part B. So statistic is like that. You write down properly because there's not much calculation. Calculation all done by calculator. Okay, in the long run, it is better for the team to play an offensive or defensive strategy. Why? In the long run, that means for most of the game, in the long run, that means you are looking at the expected value. In the long run, is it better for the team to play offensive or defensive strategy?
Defensive.
Defensive, because, give me a reason.
The expected point is higher.
Yeah, because in the long run, the expected point gain by defensive strategy is 1.1 point. But for offensive, it's only 1.05 point. Okay, now, should the strategy change if teams are awarded 4 points instead of 3 points for win? So what you need to do is, for this case, you just go to your calculator. Actually, just now, if I key in correct, if I read the whole question before I start correct, I will key this into L1. I will key this into L2, and I will key this into L3, and I will key this into L4. So that I don't have to re-key in again, I just change one value. What is the value? Award 4 points instead of 3 points for win. So I just change this to 4. The rest remain the same. Are you clear? So this is called strategy. Yeah. So never mind. I believe all of you continue to key in L1, L2, am I right? Okay, just key in again and tell me. It won't take you much of your time. Okay, can you tell me for offensive, what is the expected value?
1.35.
1.35. That is very fast. Okay, 1.35. For defensive,
1.3.
1.2.
3.
So 1.3. So you see, different situation, different awarding system you will get. So for this case, that means offensive better. Correct? So should the strategy change? Yes. Because offensive expected point is higher for this case. Okay? So you see, I can make this as one of your SAT question. So you depend on the scenario I give you. Can or not? Depend on the scenario I give you. Yeah? Okay. Can or not? So let's discuss one more question. Okay. Okay, let Mr. be very brave. Let's go to page 198. Question 8. Okay. This is a question which is very, very tricky. So you have to read the question. Without replacement again, Okay. So now, what is the variable X that is in this question talking about? Lucky 11. The player win 11 if the card drawn are the same color or one of each color. So X is the amount win. Correct? So there are only two possible values for X. Agree or disagree?
Yeah.
There are only two. That is nothing
Or 11.
or 11. Okay, so how to get 11? So in this case, I'm not going to draw a tree diagram, but I'm going to list it out. I'm going to list it out to gain 11. That means they said that all of the same color. So I have, So all of the same color, I can be first one red. You draw how many cards? 3. This is the first one. This is the second one. And this is the third one. Okay, are you clear? 3 are red or 3 are blue or 3 are green. You see, I put an or here. So that means the probability for this to happen is the n, am I right? So the first one is the red. The probability is, so in the container, how many red are there? 5. Total, how many? 12. You draw 1. The second draw, total will be 11, correct? Why 11? Because it's without replacement. Then the third one you draw 1. Then the third time you draw, you left with 10. So, first one, second one, third one. They are all together 12 inside. For the second one, 11. The third one, 10. So if the first one you draw is red, so there are 5 red inside. So you draw 1 red already. The second one will left with 4 red. Am I right? And the third one will left with 3 red. Agree with me? So for all the blue, also the same story. I hope you are following me. So how many blue are there? In the first draw, 4. You draw one blue already, you left with 3 blue. So the second draw also is blue. So now only left with 2 blue inside. So you see the bottom always 12, 11, 10. So the probability of getting all green. So if you know this principle already, correct? What you can do is three, 2, 1. So you add up all the probability. Okay, so now we are talking about all different color. When you say all different color, I can red, blue, green, red, green, blue, or blue, red, green, or blue, green, red, or green, blue, red. All are different, correct? Or green, red, blue. Okay, so I have 1, 2, 3, 4, 5, 6 possible outcomes. And the probability for each outcome, look, it doesn't matter where is the red, where is the blue. The probability will be, the first one is 12, 11, and 10. So red got 5. You draw one red, blue still got 3. Right? And you draw one blue, green. Am I right? Say blue is still got 3. It's 4. So this is 3. So if I talk about this case, so it's still the same. You see, it's still 12. So now, look at here. I have 5, 3, 4. You see, the top always is 5, 3, 4, or 5, 4, 3, up to you. That shows the number that you have. Can or not? So how in maths we are going to get this? How many combinations? Okay. So I have 3 colors. You see, the first one got 3 ways of doing it. The second one, if you fix the first one already, the second one got 2 ways of doing it. And the last one got 1 way of doing it. These are called the way. So I don't have to list it out. I can have 6. So what I need to do is the probability for all this, I add up. For this one, the probability for this whole thing to happen, I just need to times 6 for different color. Are you okay?
Yes.
Okay, so this kind of question, can I ask? I can ask. So can you please put it down? So to search for ways of arranging something, correct? You can do it like that. Okay, feeling ready?
Yes.
Yeah. Okay, can I know what is the probability of getting $11? Am I too fast?
0.3.
Yes.
Okay.
Yes.
Okay, I'll give you time to calculate. 5 times 4 times 3 plus 4 times 3 times 2. I'm not good at calculation, okay? Plus 6. So this one here. Okay, for the first one, I got 90 upon 12 times 11 times 10. Okay, I'm doing something that is very, I should cancel off, okay? This is not what a maths teacher is supposed to do. Yeah. So 90 over 1320. This for the first three, yeah. Cancel. 3 over 44. Okay, for this one, 5 times 4 times 3 times 6 divided by 12 divided by 11 divided by 10. Okay, and this one is 3 over 11, right?
Yes.
So add up 3 over 11 plus, so times 4, 15 over 44.
Yes.
Okay, so what is this one? Obviously, you just take 44 minus 15. So this is 29 over, that's why I calculate this instead of this, because this has less. Okay, so now you count the mean. So the calculation can be very messy. Okay. During your calculation, if you don't show me this is fine. You just give me this as long as this is correct. But I will advise you to show is because if here is wrong, at least I know you know how to get the answer. I may give you 1 or 2 points. Yeah, so put into the stack. Actually, if you don't want for this case, it's also very simple, correct? Do you know how I do? Okay, I don't have to put into the calculator 0 times this plus 11 times this. Divide by 11 times this, so 15 divided by 4. Is it 3 point, expected value is 3.75?
Yes.
3.75. So they say, if the organizer of the game want to make an average of 1 per game, so how much should you charge? Hello? Make means profit.
$4.75.
Yes. So that means you charge $4.75. Are you okay? Are you okay?
Yep.
Okay, so now you have a better idea of how is the thing go. Okay, I just want to let you know that if I have a probability distribution table, if you read the book, okay, now we know that if we want to count the mean, the formula is sum of xi over sum of xi pi over sum of pi. Am I right? Hello? If you have the frequency distribution table, you go like that. With sum of fi xi divide by sum of fi, correct? This is to get the mean, am I right? Hello?
Yeah.
Yes.
So, can I simplify this? Can I simplify this? Do you know the value of, what is the value of sum of pi? Can someone enlighten me? What is the value of sum of pi?
Is it 1?
Definitely is 1. Thank you. So, can I say the mean for this case now is this? Can or not?
Can.
Hello? That's why just now, for this one, I said you don't have to key into the calculator. I just take this times this plus this times this. I got the answer. You get me? So remember this. For probability distribution table, to find the mean, you use this formula. Why this formula is like that? Because of this. Hello? So do write this formula in your one-page handwritten notes. Are you okay? Hello?
Yes, miss.
Yes.
Good. Okay. Can we now solve? Do you think we still have time for the last one? Okay, never mind. The rest you try. We see how it go next week. Okay? Yeah. You try first. Hopefully by next week, I can finish chapter 7. Then we go to chapter 8. Then the week after next, we will do our SAT revision. Then we will have our SAT. So our SAT file will be in roughly 3 weeks time from now. So you better spare some time to do your homework, okay? And if you want to see how the question look like, the practice test is in Times. You can have a look at it. A lot of reading. Yeah. Can or not?
Yes, miss.
So I can only teach you the technique. Okay? So please try as many questions as possible. Okay? Class? Thank you.
Thank you, miss.
Mm.
Okay, miss.